Hello and welcome to week 6 in biopsychology, where we're going to be looking at some very interesting characteristics here about how the brain changes. If you've taken developmental psych, there's a whole section in there about the development of the central and peripheral nervous system and the changes that happen there. And certainly when I was in school, the general perspective of brain development was that it stopped, that at a very early age, probably in our early teens, maybe into our young adult years, we reached a point at which we have all the neurons that we're ever going to have. If there's any damage, nothing can be done. Neurons go away, and they don't replace. Our neurons don't have a replacement feature, similar to, let's say, an injury in our skin, where it scabs over, and then there's cellular growth to put new skin. Doesn't happen in the nervous system. Now, of course, over the years, that has been shown to not be completely true. It is true in some ways, but there continues to be neurological development throughout life. In fact, we have another word for it called, well, a couple words, experience and learning. Those actually have analogous physical representations in our brain. When we learn something new, we not only store information in our brain, we actually change its physical structure. So exciting differences based on what I learned in my intro to psych class and what we're seeing now in the literature. So we're talking about the development of the brain, those early years about how the brain becomes what it is. And then brain plasticity, which is that's sort of the new part, the further development that can happen as a result of experience and learning. In the discussion, I'm asking you to look at what happens in the brain if somebody studies the arts, whether it's drawing, painting, sculpture, dance, music. The video that I provide talks about music because that happens to be my interest, but what happens in the brain when we activate those particular things? And I want you to do the research on that. I want you to look up in the literature. If you're into dance, then let's find out what studying dance does to your brain. If you're into drawing, even if it's just a hobby and you engage in that kind of activity, what does it do to your brain, regardless of how old you are, and the changes that occur? And of course, the music one is exemplified partially in that video. So I'm having you look at and report out in the discussion board your sources and what you found out about the changes in the brain that result as a study of the arts. The quiz looks at two particular processes of brain plasticity that occur across the lifespan that represent the brain's ability to rewire itself. One is collateral sprouting. I want you to define that and the conditions under which that occurs. And the other one is disuse oversensitivity or hypersensitivity, supersensitivity. One of those. Looking at my notes now. Disuse supersensitivity. You look at those words, the nerves that are not being used become more sensitive. Describe that. And when does that happen? Maybe give us an example or something. Okay. And the final aspect here is this is a combination of developmental processes and brain plasticity, and that is someone is born deaf. Now, that person's brain has developed all the capacities for hearing, understanding language and sounds. That's all there. What happens to those parts of the brain they're all ready to go when the child is born and they're ready to start taking that kind of information in, and it's not there? Do those parts of the brain learn to do something else? Do they adapt in order to help that person survive in the world? It's interesting, for example, to know that those places are there. The parts of the brain that are usually associated with hearing are still present in a deaf person's brain, but what do they do now? Now that there's no auditory information coming in, have they found a new gig? Have they found a new job? Doing a little bit on that. You're reporting on that in a paper specifically to deafness. Now, I'm going to open this up a little bit. If you have another sensory disability that you want to look at, someone who's blind, someone who doesn't have the ability to smell things or maybe taste things, or maybe there's a condition in which a person's sense of touch and feeling is absent. If you want to go in another direction because that interests you, I'm good with that. You don't have to do deafness. Deafness is just a lot of research on it, so it's kind of easier to find that information, and there's probably a lot of stuff on blind. What happens to the occipital lobe? What does it do when a person is completely blind? Or maybe you can even look at different levels of blindness and how it affects the parts of the brain. Those, you're more on your own. I know there's a lot out there on deafness, so that's why I picked that one. And I have a personal, buy-in to the topic of deafness, being partially deaf myself. But I'm good with you coming up with your own topic. Just go with it. That'll be fun, educational for me as well. So that's our time. This week we'll be focusing on the development of the brain and its continued plasticity, or ability to change. That's what the word plastic means. It means you can bend it and it will return to its original shape. Plastic is an amazing invention for that. Not a whole lot of things that we build are like. Wood isn't like that. Metal is rarely like that. Along comes plastic. That's why we use the word plastic. It can be moved and shaped into different ways, but it also has that ability to return to its original shape. A very important quality of that material as it's used in industry, and it's really hard to find things that are not somehow plastic these days. So that's the use of that word. Little trivia for you. So enjoy that. Okay, so that's our week. You be well, and I will see you next time.